Welcome back to Year 10. So today we're looking at forces and forces in balance. This is a new unit, so we will be looking at introducing some new vocabulary, some new terms, and there is some maths in here that we need to make sure that we have mastered in order to ensure we're secure moving on. So we're going to look at three different things today. We're going to understand what is meant by the term displacement. We're going to know the difference between vector and scalar quantities. Represents vectors and quantities in scale diagrams. Okay, so these are our three outcomes. Now, first of all, we're going to either use Caboodle, which you can access using your email address onto the Caboodle site, or you may want to use BBC Bitesize or another internet-based dictionary. I can ask you to pause this slide and look for these four definitions on whichever method you choose. So here are the definitions that we need to know. So firstly, displacement. So this is the distance in a given direction without a change of direction. Magnitude, so that's about size or quantity, the physical distance or the physical size of a measurement. Vector is a physical quantity that has both magnitude and direction. And this is often a single 2-mark answer or where you have to define this in an exam. And then a scalar or a scalar quantity is a physical quantity that has magnitude only. So it has no direction. So a good example here is velocity is a vector because it has its speed in a given direction, whereas speed is a scalar quantity because it only has magnitude. Okay, it doesn't tell us the direction in which a car is travelling. Okay, so here we go. So why do we need these vectors and scalars? So in physics, we study this whole range of the world around us, and simplistically, we need to look at communicating our ideas effectively to others and communicating our predictions and making sure that we understand how these different forces, how these different entities interact with each other. So we've got some examples here down the side. We've got forces, speeds, velocities, energies, time, masses, moments, etc. And we're always looking at the relationships between these, and this is why we explore them through mathematical models more in physics than other subjects. And we're looking at, for example, if I double my speed, what happens to my braking distance? If I increase the current flowing through my circuit, what happens to the resistance? So we do need to look at how these different properties, how these different entities interact with each other and the impact of those interactions on what we're measuring. So here we are. So vector versus scalar. So in your book, so pause now, sketch out this table for me and think about whether or not something is a scalar quantity or a vector quantity. So whether we know that it is something with just magnitude, which is scalar, or it has magnitude and direction. Okay, and put these 8-9 different headings into the correct columns for me. So pause the slide now for me. Okay, so what did you get? Distance has already been done for you. Mass, okay, is a scalar quantity. Time, speed, and power, they are all scalars. Whereas velocity, acceleration, weight, and force are all vector quantities. And you can see that often through the units that they're expressed in. So we're going to talk about distance and displacement. And it's really important to think about distance and displacement as two different ideas. So distance travelled is a scalar quantity. It refers to how far an object has travelled. So if we look at the map, we can see that the person has leaving home to go to school travels via bus, and the distance they have travelled is greater than their displacement because the displacement is as the crow flies, whereas the distance that they've travelled, okay, is the route in which the bus has taken. Now, obviously, the bus can't just go straight across fields, rivers, okay, it needs to follow the road. Whereas displacement, vector quantity, just tells you how far an object is one from another. It tells you that it is moving in an easterly direction, and the displacement would always be given is in size and direction. Okay, so now we're going to look at exploring these two, distance and displacement. We're going to go through each one individually. So first of all, look at the diagram to your right hand side, and we've got a young man in the bottom left hand corner, and he's going to walk from A to B to C to D and back to A. Now, if we were calculating the distance in which he travelled, think about how we would measure this. Take a second. Yes, you're right. You would add those different distances together. So we would add 3 to 5 to 3 to 5, giving me a total of 16 metres. If the boy walks from A to B, what would the displacement be? Well, his displacement would be 3 metres north. If the boy walks all the way around the rectangle from A back to A, what would his displacement be? 0, because his position hasn't changed. The distance he's travelled is 16 metres, but his displacement is not any different to where he was originally. So challenge, what will the displacement be if he walks from A through to B to point C? You may want to use your old friend Pythagoras' theorem here to calculate this. And it is 5.8 metres northeast. So vectors. Here we have a man walking 10 kilometres north and then 10 kilometres east. And notice that you can replace these two movements with a displacement vector. So he walks 10 kilometres north, 10 kilometres east. Okay, note the length and direction of this vector. Again, we're using my old friend Pythagoras' theorem, or you can draw it out to scale. All right, so he's been displaced by 14.1 kilometres northeast. The same can be applied to velocity vectors. If the plane is travelling at 100 metres per second and in a westerly direction, then a 5 metre per second southerly direction, we then see that the plane travels 100.1 metres per second in a southwesterly direction. So scale diagrams are really good for representing vectors, and in the exam they potentially will give you, or almost always certainly give you, graph paper that is printed within the booklet to calculate this on. It really is essential that you use a suitable scale to calculate this. And you're going to use a nice sharp pencil and a ruler. And it's really important that you think about your scale being logical, because you're only really going to get one piece of graph paper. If you do it in a biro and mess it up early in the test, then you've messed up the only bit of paper that you're going to be given, because they're not able to give you any more graph paper. So here we are. This is what my man looks like on graph paper. Okay, my scale is 1 centimetre equals 10 kilometres. So you're now going to have a go. Remember, arrows need to be shown in the representing direction. Okay, you need to make sure that you put an arrow on each one, use a nice sharp pencil, and you're going to draw this as a scale vector diagram, not a scalar diagram, but a vector diagram. So my young man again walks 5 metres east, then he heads north for 20 metres before turning and walking another 5 metres east. What does that look like? Pause the slide, use some graph paper and have a go. Yeah, this is what it looks like. So my scale here is 1 centimetre per equals 1 metre. And I have literally drawn across the bottom 5 metres east, 20 metres north, 5 metres east. Perfect. That sort of thing is going to get you 3 marks in the exam, which is pretty easy to get if you just ensure that you draw your diagrams to scale and use a nice sharp pencil. Okay, so here we go. We've got some true and false statements here. So thinking about what we've already learnt and how we can add to this, I want you to look at the statements below, there's 6 of them, decide there are 3 true and 3 false. take a minute, pause the slide. Okay, so here are our answers. Displacement is a vector quantity, okay? Distance is a scalar quantity because it doesn't have any direction. Displacement and distance are the same thing. No, that's not true at all. And the size of displacement from a school, from home, is less than the distance. That is often the case when we're looking at any mode of transport. Distance is a scalar quantity. And lastly, the displacement for a school from a home could be represented by an arrow starting from a school and ending at a home. No, that is not true, because it's in the wrong direction. Okay, to make sure you've got those values down. Brilliant. So, key points from today's lesson. Displacement is a distance in a given direction. A vector is a physical quantity which has magnitude and direction. Scalar is a quantity that has magnitude but no direction, and a vector is a quantity that can be represented by an arrow in a direction of the vector, and the length of the proportion of the magnitude of the vector. Okay, bit of a mouthful, that last one. Okay, so the assignment for this lesson is a spelling test. There are 12 spellings that are important for this, and therefore this is a spelling test which is set by Show My Homework. Please have at least 3 goes in this if you do not get all of these correct the first time. Thank you. Bye.